We're going to work on Chapter 4, Section 5, just some more work with analyzing graphs of polynomial functions. You will need your graphing calculator for this, so please make sure you have the note packet for Chapter 4, Section 5, and also have the graphing calculator handy. Just a couple of warm-up questions here from the previous stuff. We've got degree, asking about degree. This has got to be degree 5. You always find your leading coefficient on whatever your highest degree is. So we have a degree 5, leading coefficient of 4. Substitute in. You would substitute in p of 3. Put the 3 in. 12 minus 3 squared. That's going to be 12 minus 9er. Has to be 3. Put the negative 5 in. Going to get... Please remember, when you put a negative in and have to square it, you're going to end up with 12 minus 25. Make sure you square before you do that multiplication, okay? And then you get negative 13. When you put in a x plus 2, make sure that you put in, we're going to have x plus 2 squared minus 3x plus 2 plus 4. When we square this, you could think about the Pascal's triangle. First one squared plus 2 times the first one times the second one. 4x plus 4. There's x plus 2 squared. Distribute, minus 3x minus 6 plus 4. Like terms, x squared plus x plus 2x. We got 4 minus 6 minus 4. We've got our answer. Very nice. The graph of a polynomial of degree 3 will intersect the x-axis 3 times. I think if we remember back to what we did yesterday, previously, we should know that it could hit it 3 times. We could go up, down, up. That's an option, right? But you could go up, and then we could land on it and go up. So that would be a way to have 2. This is 3. This is 2. And then you could have 1. So you could have 3, you could have 2, you could have 1. The answer would be sometimes. Ooh, look at that. We got an answer. Describe the end behavior. I look at the end behavior here, and I see x squared, which means it's going to either be a parabola opening up or opening down. And I know that I'll open down. It would actually be up there. I don't have to know the exact graph. I just need to know end behavior. So as we approach negative infinity and positive infinity, we're looking for both of them going to negative infinity. The y's are going to go to negative infinity. Going down, going down. All right. Determine which graph is described. I see an x cubed. I see, so if it's an x cubed, it can't be this one, right? And then I see a x cubed, so I got to be going, I'm going to be going up and down one way or another, so that's no good. And then I see a positive x cubed, and if it's positive, we're going down to the left and up to the right. Positive x cubed will always follow that track. Negative x cubed, this would be a positive x squared. This would be a negative x to the 4th. Okay, so we're going to make a table of values. Instead of just plugging in numbers, let's use the calculator. So get your calculator out and let's put in, let's put in, what was that graph? Negative x cubed minus 4x squared plus 5. Negative x cubed minus 4x squared plus 5. So we go negative x, we go negative, make sure you're using the correct functions, x cubed plus 4x squared plus 5. I think that's the right one. Negative x cubed plus 4x squared plus 5. That is correct. Okay, and then we can just go look at the table, second graph. We can get some values. There's some values that we can use. Find if you're not in a nice table, remember you might need to go to table set, but I could write those guys down. It looks like my important stuff is going to be right in here, 0, 5, 1, 8, 2, 13, 3, 14, 4, 5. If I want to look at the graph, Zoom 6 is a Zoom standard. We can see what we can see. And it looks like I can't quite see that top guy up there. That would be a maximum. So I could make my window a little bit taller. So I could go to where my Y's, go to where my Y max is, and I could go maybe up to 15, something like that. Take a look at the graph. Now we can see a lot of stuff. I can see it's a cubed. I can see my end behavior here. I can see that I'm going up there and I'm going down there. I've got a minimum, I've got a maximum, and I've got a 0. So if we're talking about estimating the maxes and mins, we can get that off the table or we can get that off the graph. So when we look at the table of values, which you should write down on your sheet, a couple of these right here, it looks like I'm coming in from infinity and I'm going down, and I have a possible minimum around 0, 5 because I went 10, 5, 8. And then I can go, I go back up to 314, right? I go back up to 314, and then I can see that my 0 occurs between 4 and 5. Okay, so we can get that table written down there, and then we can look at the graph, and we can say possible minimum at 0, 5, possible maximum at 314, and then a 0 between x equals 4 and x equals 5. So if we go back to our table of values and sketching the graph here, I can say I said possible minimum at 0, 5. Well, this isn't going to fit on here. And then we had 314. That's like up here. And then we had a 0 between 4 and 5. Knowing what we know about a negative x cubed, I got to come in from here, go up to there, and then I go zooming down, arrow up. There's our end behavior, and we're good. So we can get the important info here, here, and here by looking at our table, looking at our graph, utilizing our graphing calculator. Good stuff. We talked about this earlier in chapter 1 or 2, forget exactly, but we're talking about if we have a negative y value, we're below the x-axis, then we're above the x-axis. We had to have passed through the x-axis. That's our zeros. So remember, you can graph this sucker on your calculator, and then we can look at the table, get a table of values, and we can say, where are our zeros? And since we change from 9 to negative 1, got to be a 0 between x equals negative 2 and x equals negative 1. Go from negative 1 to positive 1. That means there has to be a 0 between x equals negative 1 and x equals 0. And then we continue on. We right here between 0 and 1, between 0 and 1. And we don't know the exact values, but we know pretty darn close. And then between 2 and 3. Those are our 4 zeros, and we can tell that by the location principle. The location principle. Okay, let's plug that guy into our calculator and see if we can find, estimate the real zeros of the function. So grab your calculator, and we can go, what was that? X cubed minus 4x squared plus 2. So I'm going to go back to y equals, and I'm going to go x cubed, and it's minus 4x squared. So I'm just going to change my guy to a minus, and then it was, what was it? Short-term memory, plus 2. So I'm going to go over plus 2. Oh, and I think, was I a positive? I got to make sure I do this right. Positive x cubed. Oh, very important. So I can edit this just by scrolling over to the negative sign and just delete that out. Okay, there we go. Positive x cubed minus 4x squared plus 2. Again, let's look at the table. When we look at the table, we can see here that we're going to have a 0 between negative 1 and 0 because I go from a negative to a positive. There's a 0 in between there. Got to be a 0 in here. I go from 0 to, so I'm going to be between 0 and 1, and then I got to have another 0 over here between 3 and 4. So if we're going to just plot those points, I'm between negative 1 and 0, again between 0 and 1. So you can just go onto your graph, and I think I was, if I can remember correctly, I was between negative 1 and 0, between 0 and 1, and then I was between, where was the other one? I forget now. Negative 1 and 0, 0 and 1, and then 3 and 4. So let's go back and put that between 3 and 4. Now, I've got some other information, but I already know this is a positive x cubed. So they told me to estimate the zeros based on that table of values, which I'll get off my calculator. I have the 3 zeros, and the maximum number of zeros I can have since I'm an x cubed is 3. So if they say estimate, we can say, you know, between x equals 0 and x equals 1. Oh, I forgot my negative 1 and x equals 0, and then 3 and x equals 4. Now we'll know, because it's positive, I'm going to go down that way. So that means I got to come up and around, and I'm going to go up here. Now I didn't get these other points exact. I just laid an estimate out there for the graph. We can look at the graph, and we can look at the table if we want to get a more thorough answer. If we want to get the exact back here, I could go to negative 1, negative 3, and I could go to, you know, I got this minimum at 3, negative 7, and then I could come up through 4, 2 if I want to, but they didn't ask me to graph an exact. I could plot those points. They just asked me for the zeros. Same idea, make a table of values. I've got the table of values right here. So we plug this into the graphing calculator. And now if it wants to estimate the x coordinates where the maximums and the minimums occur, so we've got zeros. I've got from a negative to a positive here. That's a 0 in between negative 1 and negative 2. And then I can see a maximum there. And I'm 1, 5, 3, 3, 1, 5. Has to be a minimum. So we're looking for those low values and those high values. Here's our graph. I got a 0 between negative 2 and negative 1, going to be right there. And then I've got a maximum here at about 0, 5. Got a minimum here at about 2, 1. So between the table and the graph, we should be able to estimate these max and mins fairly easily by using our graphing calculator. Same idea, x cubed plus 3x squared plus 2. Let's take a look at just a couple more here. X squared plus 3x squared plus 2. X what? X cubed. X cubed plus 3x squared plus 2. Let's try again. X cubed plus 3x squared. 3x squared. 3x squared plus 2. Did I get it? X cubed plus 3x squared plus 2. I got it. Okay, graph that one. Take a look at the table. On the table of values, we can see a bunch of stuff. Knowing what you know about x cubed, down to the left, it looks like I've got a 0 between negative 4 and negative 3. Now let's find some max and mins. I go negative 14, positive 2, positive 6, positive 4. Negative 2, 6 has got to be a max. From 6 down to 4, down to 2, up to 6. 0, 2 has got to be a min. So I've got a 0 between negative 4 and negative 3. I've got a max at negative 2, 6. And then I've got a min at 0, 2. So we'll be coming up and then coming back down. So I've got a 0 between, I already forgot where it was. My 0 is between negative 4 and negative 3. 0 between negative 4 and negative 3. So I can plot this, my 0 between negative 4 and negative 3. And then I've got negative 2, 6. and then I had 0, 2. Knowing what I know about positive x cubes, that's enough to sketch the graph because I got to go up forever. Again, these are not exact, these are estimates. 0, max, min. We got it. Okay. Here's a couple more. You can do this one with your graphing calculator on your own. Notice it's a negative x cubed, so please make sure that you have it. Your general shape is going to look like this, just based on what we know about negative x cubes. Here's an x to the 4th problem, and this one's going to end up. This one's going to look. It's a positive, right? So it's probably going to look like that. Okay. So now you can find, you'll have a minimum, maybe a maximum, maybe a minimum, and you could have up to 4 zeros. You might have 4, you might have less, and you can do that one as well. Let's take a look at these last things. You can already tell a whole bunch of stuff about these graphs. Estimate the x-coordinate of the turning points and determine if those are maximums or minimums. So this should be pretty easy. We've got a max here at x equals -3, right? Got a max, and at x equals, that looks like 1.5, right? Got a minimum here, minimum at x equals -1/2. Got zeros, if they want the zeros. I got 2 zeros there between -4, -3. Zeros between x equals -4, x equals -3. And then you've got zeros between x equals 2 and x equals 3. You know, there's the 2 zeros. And then this would be a negative lead coefficient, and this would be a possibility of a 4, because I got 3 humps and bumps, and down and down. It's a possible degree equals 4. This would be a degree 3. This has 1, 2, 3, 4, 5 humps and bumps. 1, 2, 3, 4, 5, 6 zeros. So this would be a possible degree 6. Number of possible zeros equals number, the biggest degree. And this would be a 1, 2, 3, 4. This is a degree 3. Got a max there, got a min there, got a couple of zeros, got a minimum and a minimum and a minimum and a maximum and a maximum, and you can find all those values. Same thing over here, minimum, minimum, maximum, got a bunch of values. Notice all these domains are -infinity to infinity for all of them. And then the range of the odd ones here, odd one, would be -infinity to infinity. This guy over here, -infinity to 5. This guy over here looks like about negative, I don't know if that's -7 to infinity. This one looks like about -4 to infinity. So remember, range is up and down. Okay, let's slide over to, I'm going to slide over to these ones at the end. Right here. Yeah, these are great problems. I don't think we need all these graphs. We just need one. It says graph a third degree function, degree 3, with these 3 zeros. I'm going to go -5, -1, +3, and a minimum at 2. So a minimum at 2. I'm just going to throw one down here. I don't know exactly where it is. And a maximum at -4. So knowing what we know about maxes and mins and x cubes, they didn't tell us if we're going to be down to the left and up to the right, but I can kind of make the assumption that I'm going to go something like this. Can you see that there? Can you see x cubed, 3 zeros, 1 max, 1 min? So we're just taking the information they give you, and this is one graph. Does yours have to look like this? Nope. I could have -5, -1, +3, a maximum right here, a minimum right here, and I could have this lovely little sucker, and that meets the criteria as well. Or maybe you want to get crazy. I've got my 0 here, 0 here, 0 here, maximum at -4, minimum at 2, and I go, whoa, cats, look at that guy. That's terrible. Okay, but hopefully you get the picture. Last one, 4th degree. Let's see what we got. Let's see if we can do this. I think we can. 4th degree with a 0 at -2 and a 0 at positive 2, and a maximum at 1. So let's put it like there. Now, knowing what we have about fourth degree is the George W. Bush, I think. So we want to maybe come down here. We want to just maybe touch that, because if I go under, I'd have to have more zeros. And then I could come down up here and I could touch that, and then I could touch that and go away. So we've got the kind of the W there, and I met the criteria. Notice since I'm degree 4, I got to be up and up, or down and down. Sometimes fourths can look like squared, so you could actually have one that maybe comes up here and then there's a squiggle in the middle and then it comes down. That would work as well. I know that one would be harder to interpret, but the general consensus would be this one over here. So there you go. We got an answer sheet that you can do the problems with. We'll get that answer sheet handed out that has these problems on it, and you'll be able to do the homework for 4.5. Again, when it says make a table of values, you can use your calculator for that. All right. Have a great day.